time to reassemble the spindle, and I think I found the source of my problem. It looks like someone hand ground a chamfer on the small end of the journal, and this left a raised edge that damaged the bronze bearing. You can see a groove on this photo, and I believe this was caused by the raised edge. It certainly lines up very nicely with the raised edge. That raised edge wasn't a problem till I did some scraping on the bearing earlier this year. Before scraping, the spindle was only running on this thrust part of the bearing. So I scraped a bit off, and that moved the journal deeper into the bearing, and the raised edge became a problem. Scraping, however, also improved the deflection of the spindle a lot, and together with some other light scraping, I got the spindle running quite smoothly. I thought I was winning, but clearly I was wrong. I've been working this journal for maybe 20 minutes now, and I can still feel that there is more drag over here than there is here. So this stuff must be really hard. I guess it's better to take off a little extra than to leave a high spot. I don't expect this end of the bearing to do much anyway. Not after the damage caused by the raised edge. This ring that rides up against the rear of the bearing has been giving me problems since I started using this lathe. I did stone the surface, but well, somehow the problems never went away. So I took a measurement. It is not there is a bit of a fixed spot somewhere, so I'm going to clean it up on the lathe. I'm going to regrind the surface. I will probably also clean up this surface on the lathe and then remount it using some glue. That way it won't be pushed forward again when I hammer out the taper. So this is a total failure. This just flexes too much and it vibrates, and you can actually feel the vibration in the cable that runs to the Dremel tool. I'm getting a horrible surface finish. So I gotta come up with a plan B. Plan B. It's ugly, but as long as it works. The vibration of the Dremel tool is causing it to move. So I gotta crush it a little, I guess. The grinding left a very poor surface finish, and there is still a 2 or 3/100ths of a millimeter thickness difference. So now I'm going to work it on the stone and hopefully improve the finish a bit. That little grinder was just vibrating too much to be any good. I took some measurements, and it looks like there is no uneven wear, so the brass bearing seems to be worn evenly. There's also quite a bit of copper oxidation here, and there was also copper oxidation here. So it looks like the green stuff, the copper oxide, was everywhere, where the journal wasn't in close contact with the bronze bearing. So maybe there was some condensation, some water in there. So now I gotta see if I can get that out without damaging the bearing. And then I will put it in the lathe and face this side off, so all the so the groove is gone, and the all that nasty spot is gone. It's only a very slight groove, and all the copper oxide is gone, because I think the copper oxide is harder than the bronze, and might damage the hardened steel spindle. I'm ready to screw up this bearing once and for all, although I did my best to well, prevent that from happening. I first checked the chock, if the facing surfaces are in one plane, and they were within a hundredth of a millimeter. I used a piece of shim stock to prevent damaging the brass. I used a nylon hammer to tap it in place. I got myself a brand new bit with a nice radius, and well, it's time to take a cut. The result looks very good, although I'm not happy, because I measured it with the calipers and there is a difference, and I couldn't measure that before with the calipers, so I don't get it. I even stoned the surface before I put it in the chock. The chock was within a hundredth of a millimeter. The face of the chock was within a hundredth of a millimeter, and now there's maybe, well, maximum a tenth of a millimeter difference. That pisses me off. The surface of this bore is pretty rough. I was expecting something a bit smoother. Making sure I got the oil hole lined up. This Loctite is anaerobic curing. So that means it hardens in a airless environment, and it takes about 24 hours to cure. I thought about using CA glue, but that isn't really temperature resistant. Yeah. It goes in easy enough. And now I get to do a little finger painting. This is way too much. I'm using oil paint instead of, well, engineering blue or whatever it's called. Gotta line up the rear bearing. It feels pretty smooth. It is oil paint. Well, that doesn't look very good. It actually looks better on camera because the blue is reflecting inside the bearing. There's only blue on this part, this side of the bearing, and there's only a bit here on the taper. So reseating the bearing changed things quite a bit. There's hardly any contact in the rear where I ground the journal. When I did my scraping earlier this year, I thought I got it pretty good, but well, now it doesn't look very nice. I removed this protection ring. I was worried it might push up against the bronze and disform the bearing, but I don't think that's the case. So there's a definite high spot here, and I will now scrape that down a bit. And I thought I found a scraper, but it is shit. So I will be using my pocket knife again. I'm not sure if I can do this with the camera in the way. Yeah, I'll switch you off. I had the spindle in and out a few times, and I did some light scraping, and I'm making progress because there is now contact almost all the way around on the thrust part of the taper. Here it isn't touching, but there's hardly any contact on this side of the bearing in the shallow part of the taper. So I will remove a little more, and hopefully the bearing will get pushed a little further inside, and there will be a bit more contact. I've got good contact on the thrust part of the bearing, but still on this side there's no paint. So for at least 40% there's no contact. That's quite a lot. Now, it wasn't perfect before. This side was also a problem when I scraped the bearings earlier this year, and I'm not sure why it's gotten worse. I think it might be the reseating, but it could also be the grinding I did on the spindle journal, or maybe it's because of the spindle seizing up and the damage that caused. Not sure. The bearing was a bit tight on this side. There were a couple of grooves on the outside in this direction. So I did chamfer the bearing a bit on this side to make it go in easier. So it is possible that the bearing got pushed a little oval. That would explain this. I think I will leave it like this for now. The spindle is a bit grooved on the tapered part of the bearing. So if those grooves wear in to this surface, it might push the whole spindle in further, and there might be more contact area as a result of that. Let's see if I can reassemble this in 5 minutes. there was quite a bit of black rust inside this groove, so I had to remove it with some acid, because scraping just didn't do it. Put some grease inside the pulley, because the inside rust pretty easy. I coated this in some oil because this machine surface was already starting to rust. Maybe condensation, or perhaps there was a bit of water in the oil. And of course I forget the belt. Oh fuck! Well, I'm not gonna film that again. Alright, the belt is installed, and it's now time to adjust the spindle. But first, some oil. I'm using some ISO 32 hydraulic oil. I tried to find some old school oil without detergents and additives, but you need a time machine to get that stuff. The only thing I could find was for old tractors, and that was a 30 weight oil, and that is about ISO 100, and that's thicker than I would have liked. When setting up this spindle, I relied on feel and heat, so I monitored the heat, and if it got too warm I backed off this ring. This time I am going to put a feeler gauge in there, and that's a 1/10 of a millimeter, and then lock things up. It feels good. Hopefully it is good. The adjustment of the rear bearing works a little different, because the rear journal is basically a sleeve that fits over the spindle. So you need to move it in or out of the tapered bearing to set up the proper clearances. I think I will push it in with this feeler gauge till it starts to bind. It's already binding. Remove the feeler gauge and then tighten up this one in the rear. And hopefully that'll do the trick. It feels okay. not much heat built up after 10 minutes of running, but it is really pissing through the oil. It's already gone. It is even dripping on the front side of the headstock, which it never did before. Great. Will it never end? So now you get to see how much I screwed up this time. And then I'll quit this video because it's getting way too long and boring. Well, I certainly haven't improved things. And I think runout was 2/100 of a millimeters before, and now it is at least 300, so that's 1/100 of a millimeter screw up. The end.